In this video, we'll continue our multiple choice related rates AP problems. We come to 1988 AB 40. We have the sides of this rectangle above increasing in such a way that dz dt is 1, dx dt is 3, dy dt. At the instant when x equals 4, y equals 3, what is dx dt? And so we have the rectangle drawn there. With the diagonal, we can clearly see that we're using some kind of Pythagorean formula for this. So that will give us the formula to relate the different rates together. And so there we'll start with z squared equals x squared plus y squared. Differentiate both sides with respect to time. On the left we get 2z dz dt. On the right, so the first term would be 2x dx dt, the second would be 2y dy dt. The 2's will cancel across, leaving us with z dz dt is equal to x dx dt plus y dy dt. The calculus is done. Now we can plug in. We know that x is 4, y is 3, and so z is going to have to be 5. We also know that dz dt is 1, and we can replace dx dt with 3 dy dt. So I'll continue below. So I have 5, which is z, dz dt is 1, is equal to 4, which is x, dx dt will be 3 dy dt, then y is 3, and dy dt. Simplifying, we get 5 is equal to 12 dy dt plus 3 dy dt, which is 15 dy dt. Solving for dy dt, we get 1/3. And that's one of the answers, but that's not the quantity we're looking for. We're looking for dx dt. We know that dx dt is 3 times dy dt, so it's 3 times 1/3, which is 1, and that is the answer we're looking for, B. We'll pause here for a second and go on to the next problem. Okay, we'll continue with the next problem. 1988 BC 37. A person 2 meters tall walks directly away from a street light that is 8 meters above the ground. So we start with a street light that's 8 meters tall, and the person is 2 meters tall. And we have the person who is 2 meters tall walking away, and then we have the shadow cast from the light over the man's head down to the ground. And that will form this set of similar triangles here. Now, since the person is walking away from the street light, he's moving in the positive x direction. Now, if we picture this as superimposed on an xy coordinate plane, the person's position we could consider x, and the rate at which that x coordinate is moving along, or that coordinate is moving along the x-axis, would be dx dt, which is in essence what we're looking for here, the rate in meters per second at which the person is walking. Now we still have to deal with the idea of the shadow. The shadow is really the length of the segment from where the person is to where the light begins to hit the ground again. And that point at the end would be x plus s, which is the length of the large triangular base. So we have enough there now to set up a proportion. The height of the large triangle over the base of the large triangle would be 8, and meters is a unit, not a variable, 8 over x plus s, and that's equal to 2 over s. And we can cross multiply to get 8s is equal to 2x plus 2s. Combine like terms. 6s is equal to 2x. Now we can differentiate with respect to time. 6d s dt is equal to 2 dx dt. The rate at which the shadow lengthens is ds dt, or 4/9, and dx dt is what we're trying to solve for. And that ends up being 12/9, or 4/3 meters per second, which is choice D. And so there's a lot going on here, but once you've seen how this works with the shadow length and the person's distance and both of them changing, it should be pretty straightforward. And the solution uses similar triangles. And that'll do it for these two problems.